Friends, now we will start with our last topic of this course, additive manufacturing. So, let us see some historical development of the subject additive manufacturing. So, it is basically the manufacturing of prototypes. Okay, so the term of this additive manufacturing is basically deals with the rapid prototyping technique. So, the term rapid prototyping is used to describe the process for rapidly creating or fastly creating the part or prototype or system before final release or before its commercialization. The term prototyping is basically derived from the Greek word prototypon, where proto means the first and typon means form, the first form. It is the first order primitive form of the design taking into account all the steps and norms. That is prototype. So all the norms from the design department or the norms from the manufacturing department, by considering all these norms, we are physically developing the product from the given design. Okay, so in simple manner you can also say that it is a first physical form of the design. But as far as the management consultants and software engineers, the term rapid prototyping is a process of developing business and software solution only. But in the product development context, the term rapid prototyping used widely to describe the technology which develops the prototype directly from the digital data. See, the development of prototype is very important thing in the industries. The management people, they want to develop these prototypes at the faster speed or in the minimum time before their competitor develop the same product. Okay, so these are the business strategies. So that's why they required to make this prototype in a shorter period of time, and that's why the making of this prototype within a short period of time, the term is known as rapid prototyping. Means we are producing this or manufacturing this prototype rapidly. Okay, so the users of this rapid prototyping technology, have come to realize that this term is inadequate and not effectively describe the more recent applications of this. So many parts now directly manufactured in these machines. So the machines by whom we are producing these prototypes, these are no more only producing the prototypes, but we are producing the final parts from these machines also. So it is not possible for call these machines or the process or label that part which are produced by these machines as a prototype. Okay, so the basic principle of this technology in that they all fabricate parts using the additive approach. So in these RP developing machines, the basic principle is that the parts are made by using the additive approach. So material is added here, material is not removed, material is added here. We will see how it is added, but we are talking about the development of this subject or this topic, additive manufacturing. So the recently formed technical committee within the ASTM, that is American Society for Testing Materials, and they agreed that the new technology has to be adopted. and they name that technology as additive manufacturing. Okay, so this is actually the historical development of this additive manufacturing from the process of rapid prototyping. Okay, now let us see some fundamental things about the rapid prototyping. So here the basic principle is that the model initially generated using three-dimensional computer-aided design, that is CAD system, and can be made directly without any need of the process planning. Now see here, why without any need of process planning? Now if we compare this technology, that is RP, with the other manufacturing processes, so the thing is that the other manufacturing processes required the careful and detailed analysis of the part geometry, the order of making, the holding devices like fixtures. But the AM needs only the dimensional details, or you can say little understanding about how the AM machines are going to create that part, or some material details they will require. Okay, but in traditional or in other processes we require all the things. We have to carefully study the drawing, carefully study the part geometry, order of making, sequence of making, which machineries, tools we are going to use, all these things. But additive manufacturing eliminate all these hurdles. Okay, now the key to how M work is that the part is made by adding material layer by layer, that is additive approach. See, layer by layer we are going to add these layers, one or another, one or other, very thin layers actually, and that layer will finally develop our prototype. So here the each layer is the thinner cross section of the part derived from the CAD data. Okay, whatever the information we are having from the CAD, so that geometry we are putting in terms of a thin layer, and this thin layer one or another are creating the prototype or part. See here, so you can see here the effects of building using different layer thicknesses. So here, thinner the each layer, closer the final part will be to the original. See, so here layer by layer, layer by layer, you are go on adding these layers, and at the end integration of this, you will see the final product, right? So this is known as the additive approach. This is the additive approach. You are adding the material layer by layer, right? Good. So only the thing is that we have to understand about what accuracy, what material properties or mechanical properties, what are the post processing things, and how quick we can make the part in this AM system. And also at the same time we have to think about, or we have to uh, put our minds on the overall cost of these machines and processes. So these are the things we should study before going into process. Understood? Good. Now let us see the advantages of rapid prototyping. Now compared to the simple model making technique, this AM or RP developed as the materials, accuracy and overall quality of the output improved. So output of these prototypes is improved in the all manners of materials, accuracy and overall quality. And the models are quickly employed to supply the information. So what are the models or parts made by this technology? They will give you or supply you the information about the 3Fs. Now what are the 3Fs? So first F is form, second F is fit, and third one is function. So if you look, the initial model were used to help fully appreciate the shape and form. Shape and form means the general purpose design. that is a shape and form. These are two F's. And improved accuracy in the process help to make product with the required assembly fit. This is third F. Why? Definitely, when we produce something, then to make the final product, it has to be get assembled with some another product, and in assembly we require the requirements of the fits. So improved accuracy in this technology is helped to make the product with the required assembly purpose. Okay, and required assembly purpose is only can be possible with the required fits. Okay, now see here, this additive manufacturing in conjunction with the other technologies to form a process chain can significantly shorten the product development time and cost also. See, the intelligent chain or linkage of this additive manufacturing with the other technologies definitely is going to reduce our product development time and cost also. So here, using the high power laser technology is mean the parts can directly made in the variety of materials, and which is extending the application range even further. See, using of high power laser technology has meant that parts can directly made in a variety of materials or metals, which is extending the application range even further. Now let us see some applications of these AM parts. Okay, so which are the fields where the AM technology is adapted? So aerospace and defense, then automotive industry, then machinery like turbines and special machineries, handling and robotics, in the lifestyles and sports, in the medical implants, and in the custom parts. Now, if you look at the aerospace and defense industries, so these companies are the number one early adopters of this AM technology, and they are first one to move ahead from small research projects to the large scale production runs. So, aerospace and defense industries are the first adopters of additive manufacturing. If you look at the automotive industries, so basically they employing the 3D printing since years for rapid prototyping, focused on pre-production of single test parts. So automotive industries also are in this technology since years. They are using the 3D printing techniques for developing the prototypes. If you look at the machinery like turbines and special machineries, they are using this additive manufacturing. Then it is used in the handling and robotics also. Now if you look at the lifestyle, so jewelry is the best application of the additive manufacturing, and in sports it is used in the biking. You can see the pictures here. See the jewelries, the surgical instruments, devices. Okay, then the sports, electronics, tool making. Okay, so these are the industries where this additive manufacturing is used. Okay, if you see the medical implants, so it is very famous in the see dental and orthopedic parts of this medical industry. And in the custom parts we are having the classical cars and the surgical tools, where the AM plays the very important role. Okay, so these are the applications of additive manufacturing.